Okay, so it is important to note that you can only substitute changing quantities into the equation after the differentiation has occurred. It's not going to work before, so it has to be fully differentiated, and then you're going to substitute in actual values. So, for example 7, when it says how fast is the area of a circle increasing when the radius is 3 centimeters and the radius of the circle is increasing at a rate of 5 centimeters per second. So we know that we're dealing with the circle and we have our radius. We know that we're dealing with the area of a circle, which is pi r squared. In this case, we have A is the area, R is the radius, and given this problem, T is time again. We know the area and the radius have to be greater than 0, and we know that the time has to be greater than or equal to 0. We also know that we have, at this point, dr over dt, which we're given here, over time, is 5 centimeters per second. And we know that the radius, given this problem, at this point is 3 centimeters. We're trying to find what the change in the area is over that time. So we're going to take our formula and we're going to differentiate it. So if A is equal to pi r squared, then dA over dt is going to equal pi and 2r times dr over dt. And this is all happening when r is equal to 3, and we already know that dr over dt is going to be 5. So dA over dt is going to equal pi times 2 times r, which is 3, times dr over dt, which is 5. And that's going to give me 30 pi. And because this is area, this is in centimeters squared per second. So we can state, therefore, the area of the circle is increasing at a rate of 30 pi centimeters squared per second when the radius is 3 centimeters. For example 8, a spherical balloon is losing air at a rate of 10 centimeters cubed per minute. How fast is the radius decreasing when the radius is 5 centimeters? So I have my balloon. I have my radius. And I know that the volume of the sphere is equal to 4 over 3 pi r cubed, where V is the volume, R is the radius, and T is time. And V and R have to be greater than 0. T has to be greater than or equal to 0. What else do we know? We know that dV over dt is equal to, it says it's losing air, negative 10 centimeters cubed per minute. We also know that we're searching for this when R is 5 centimeters. We're trying to find dr over dt. So if V is equal to 4 over 3 pi r cubed, then dV over dt is going to equal 4 over 3 pi and then 3r squared times dr over dt. Well, the times 3 and divide by 3 are going to cancel each other out. So I'm going to say that dV over dt is equal to 4 pi r squared times dr over dt. And we know that this is occurring when r is equal to 5. So we're going to substitute in what we know. And we know that dV over dt is negative 10. And then I have 4 pi r is 5 squared times dr over dt. And the dr over dt in this case is what I'm trying to solve. So I'm going to simplify this. 5 squared is going to be 25 times 4. Negative 10 is equal to 100 pi times dr over dt. Divide both sides by 100 pi, and dr over dt is going to equal negative 1 over 10 pi. And this is, because it's radius, centimeters per minute. And then we do our statement. The radius is decreasing because it's negative by negative 1 over 10 pi centimeters per minute when the radius is 5 centimeters. Question 9. A pebble is dropped into a puddle of water, causing concentric circular ripples. So obviously it's a circle again. If each ripple moves outward at a rate of 1 centimeter per second, at what rate is the area of the circle of ripples increasing when the radius is 5 centimeters? So we have, it's dropped in here, and then I have concentric circles which are moving further and further out for my radius. I'm dealing with the area of the circle. So the area of a circle is pi r squared. We know that A is going to be the area. We know that r is going to be the radius. And we know that t is going to be the time. And this is where A and R have to be greater than 0. And like in all of our previous examples, time has to be greater than or equal to 0. We also know, based on what we see here, that the radius is moving outwards at 1 centimeter per second. So we call that dr over dt is 1 centimeter per second. And we know that we're solving for when the radius is 5 centimeters. And we're trying to find what the change in the area is over time, dA over dt. Which means that we're going to take this and we're going to start by differentiating that area formula. We're going to say that dA over dt is going to equal 2 pi r times dr over dt when we simplify it. And this is when r is equal to 5, which means that dA over dt is going to equal 2 times pi times my r is 5, and my dr over dt is 1, which is going to give me 10 pi centimeters squared per second. Therefore, the area of the puddle or let's say the area of the circle. You could also use the area of the ripple, is increasing at a rate of 10 pi centimeters squared per second when the radius is 5 centimeters.